Okay, in this lecture we're going to move to the next level of difficulty for inequalities. From linear inequalities we're going to go towards quadratic inequalities. And you remember that a quadratic has this form. And when we were looking at equations it would be equal to 0. So when we're talking about inequalities we can talk about this either being less than 0 or less than or equal to. So we could use less than or equal to. We could use greater than or greater than or equal to. So we could have this being greater than 0, or we could have greater than or equal to. Alright, same thing here, of course, a can't be equal to 0 or we wouldn't have a quadratic. Right, now the way we do this is we follow the following steps for solutions. Solution procedure is 1. Alright, solve the quadratic equation. So first of all we solve this part where it's equal to 0. Okay? Right, then we identify the intervals produced by the solutions, right, in number 1 step. Okay? Alright, and then number 3, we test the truth of each interval. So we're going to take a value in that interval and see whether it's true as far as the inequality is concerned. So let's do an example. Right, let's suppose I want to solve x squared minus 2x minus 15 is less than or equal to 0. Well, notice in standard form first, so our first step is always to make sure it's in standard form. Right, so step 1, alright, check for first of all for standard form. And of course standard form is this ax squared plus bx plus c is less than or equal to or greater than or equal to 0. Alright, then factor, alright, the quadratic. The quadratic, here it is, x squared minus 2x minus 15 equals 0. So you may remember we did this in earlier in algebra, that we were looking for factors of negative 15 which add up to negative 2, and that of course would be, let's have a look, 3 and 5 I guess. So one of them's going to have to be positive, one's going to have to be negative, and since we've got a negative in here it would be the largest one would be negative, so I'd end up with this. So let's check it by foiling it. It would be x squared minus 5x plus 3x is negative 2x. 3 by negative 5 is negative 15. So this implies that x is equal to negative 3 and 5. Alright, so we've solved that. Okay, step 2. Best way to do this is to draw a picture. So let's suppose here's 0. So 1, 2, 3. So here's negative 3. 1, 2, 3, 4, 5. Here's 5. Now, these are the equal ones. So I'm going to put a dashed line down there to separate these out. Now, notice that we do have an equal to, so we're going to include these two values. All right. But I really, at the moment, what I want to do is identify 3 different intervals. Well, there's the interval that's less than minus 3 down this way, the interval between negative 3 and 5, and the interval that is greater than 5. So what we do is we take a test value. All right, so step 3. All right, use test values. Right, so let's, for example, we take a negative 4 over here. What happens when x is equal to negative 4? This implies what? If I come up to here, I'm going to have negative 4 squared, Okay, minus 2 by negative 4, subtract 15. What do I get? I get 16 plus 8 minus 15, which of course is 9, which is positive. So that's saying less than or equal to, I've got a positive, so this is a false solution. So it's not true, so notice that this is positive over here. I'm going to put a positive number there. We're looking for a negative, all right? Next we could use x equals 0. It's always an easy one. So this would mean I'd have 0 squared minus 2 by 0 minus 15, which of course is negative 15, which is less than or equal to 0. So this is true because I get a negative in here. And if I come across here and use 6 on the other side here, when x equals 6, then I'd have 6 squared minus 2 by 6 minus 15 is equal to 36. Minus 12 minus 15, what's that, 27, so that's 9 again, so this is equal to 9, which is positive. So again, this is false, right, because we've got a positive here. So I'm looking for when it's less than or equal to 0. So of course it's going to include negative 3 and 5. So my solution is an interval which is negative 3 to 5, like so. And that's how we would solve this particular type of problem. Alright, so if I was to do this now, so let's call that example 1. And now we go to example 2. Let's suppose I want to solve 3x squared minus 11x minus 4 is going to be greater than 0. So again, what we first of all do, number 1, is we use 3x squared minus 11x minus 4 equals 0. Let's see how we can do this. This would be a 3x by something. A 4 would perhaps be a 2 and a 2, although we need an 11, so it may be that we would like a 4 and a 1 perhaps would be workable. So this would be 12, so we need a negative 12 and a plus here. Okay, check that it's true. It's very important that you can factor these. Okay, now we have 3x squared minus 12x plus 1x is negative 11x, subtract 4. So notice here I have 3x plus 1 equals 0, so I get 3x is equal to negative 1, or x is equal to negative a third. Alright, secondly I have x take 4 equals 0, so therefore x is equal to 4. Right, so let's do break up our number line here. So let's suppose here's 0, so I'm going to have negative a third here. And I have, say, 1, 2, 3, 4 here. So here's 4. Right, so here's our 3 different parts of the interval, and we're now looking for when it's positive. I'm looking for a positive. So here, of course, I have a negative 1. So let's have a look at a negative 1. And we'll have 3 by negative 1. So here we have x is negative 1. We're going to test. So squared minus 11 by negative 1 minus 4. What do I get? I end up with 3. That should be a 1 there. Plus 11 minus 4. Okay, so this will be, what's that, 14, so this will be 10, which of course is positive. So this would be true, because this would be our positive right here. What about when x is 0? Then I'll have 3 by 0 squared minus 11 by 0, which of course is 0, minus 4 of course, which is equal to negative 4, which is less than 0, so this would be a false result, and that's a negative right there. Okay, when x is equal to 5, I'd have 3 by 5 squared minus 11 by 5, subtract 4. Okay, so this would be 75 minus 55 minus 4, so this would be 20, so this would be 16, which again is positive. So it's true, positive here. So when I'm looking for it to be positive, okay, we're going to have from, so here's our solution, would be negative infinity to negative 1/3. Now we're not including 1/3 because this is greater than, all right, so it's a round parentheses. And of course we'd have from 4, not including 4, to infinity. We join those together by this symbol, which means union, join together. So it's this particular interval plus this interval, and that would be our solution.